In this video here, we're going to use integration to help us find the area between two curves. So it's a little bit more complicated than what we've looked at before, where we're finding the area between a single curve and the x-axis. So this first example here, we're going to find the area between the curves y equals x squared, so this parabola here, and y equals 2 minus x squared. These have been drawn for us already, and they have both been labelled. The limits have not been implicitly stated. We have not been told anywhere in the question what to use. However, if we study the graph, we can see where our limits lie. Our area is going to have an upper bound here at this x coordinate of 1. It's going to have a lower limit at this point here, where I have got an x coordinate of -1. Now, we have got a little bit more work to do before we actually get stuck into our integration. Our area is still going to be found using integration. However, we are going to have to do the top function subtract the bottom function. We're going to integrate whatever that is with respect to x, and we have got our two limits at 1 and -1. It is vital that you have these in the right order, that you do the top function subtract the bottom function. If you get these in the wrong order, you're going to lose a whole heap of marks. The top function is going to be this one here, the one that forms sort of the top boundary. That is this equation here. So the top is this 2 minus x squared. The bottom is this bit down here. So this is the bit that's forming the bottom of my area. And that's going to be that function, x squared. I'm not going to do any integration yet. So I still have my integral symbol. My limits are still the same. And I am going to do the top function minus the bottom function. A little bit of overkill with the brackets here because I have got this thing and I'm going to subtract an x squared from it. So I am going to have 2 minus, well, I've got minus x squared minus another x squared. So I'm going to have minus 2x squared dx. You should, once you've got this set up with your top function minus your bottom function, you should always tidy this up before you do any integration. So down here you see I've got these 3 long integration symbols to show I have not done any integration yet. That's what I'm going to do now. 2 is going to integrate to 2x. Minus 2x squared, well, the x squared will go to an x cubed, and I'll need to divide by that 3. So I've got 2 over 3 as my coefficient. I don't need to put in the plus c because I'm substituting limits in, so this is what we call a definite integral. Now, at the substitution stage here, don't do any number work. Just rewrite your integral with the 2 limits substituted in place, and that'll guarantee you a mark. So I am going to have 2 times 1 minus 2/3 of 1 cubed, subtract, plug in the second limit, 2 lots of -1 minus 2/3 of -1 cubed. This is the sort of thing we need to be able to do without a calculator. I'm going to end up with 2 minus 2/3, because the 1 cubed, well, that's just going to be 1, minus -2. Now, -1 to the power of 3, -1 cubed will be -1. -1 times -2/3 will give me plus 2/3 equals 2 take away 2/3, that's going to be 1 1/3, minus negative 2 add 2/3, that is going to be negative 1 1/3. 1 1/3 minus negative 1 1/3, well, that's going to be the same as 1 1/3 plus positive 1 1/3. So that will give me 2 2/3 square units. If you have set this up correctly, you will always get a positive area. So this is why this bit up at the top is super important. You must do the top minus the bottom. If you end up with a negative area at the end of this, you have done this wrong. It will not be enough just to get rid of the negative and say, oh, I should have a positive area here. If you end up with a negative area, you have got these in the wrong place. You'll be doing bottom take away top. So if that's the case, you need to go right back to the start and change the order this is written in here. Right, here's another one. Same sort of setup, but there's a slight difference. We've got two quadratics crossing over and an area shaded in. The problem here is we do not have the limits marked on our graph. We can see there's a point of intersection here, and we can see there's a point of intersection there, so we know there are limits. However, we don't have a grid to read the coordinates off of, and we've not been told what they are. Our points of intersection, these are going to be our limits. To find the point where two curves intersect, we take one equation and set it equal to the other. What we are essentially doing is we're saying the y for this one is going to equal the y for this one. I've got a quadratic equation here, so I'm going to bring everything over to one side and solve it. So I'm going to add an x squared to each side. That'll give me 2x squared. I'm going to subtract 4x, and I'm going to be left with a negative 6 on the left. By doing that, I'll have a 0 on the right. I'm going to factorise and solve that equation. So the easiest way to factorise this, I'm going to divide everything by 2. So that'll give me x squared minus 2x minus 3 equals 0. So dividing the right hand side will still give me that 0. It's a unitary quadratic, it's 1x squared. So I should be able to just jump straight to its factorised form. Negative 3 plus 1. So this gives me a solution of x equals 3, x equals negative 1. Those are my limits. So my two curves cross at x equals 3 and at x equals negative 1. So I can see from the graph, the sketch I've got, I can see one positive and one negative. Now that I have found up my limits, I can set up my integration. Area is the integral, I'll pop in my limits just now, of the top minus the bottom with respect to x. Top, it's this function here. So this is this quadratic. So I'm going to have my area is 4x minus x squared minus the bottom. So that is this one here. It's going to be that quadratic. X squared minus 6 dx. I'm going to multiply out these brackets and tidy it up. So still got my integral symbol because I've not done any integration. 4x minus x squared minus this bracket, so I'm going to have minus x squared plus 6. So be careful that negative 6 has got multiplied by essentially what is a negative 1. So I'm not integrating, so I put my integral symbol down, and I'm going to tidy this up. Well, I've got a 4x there. Negative x squared will give me negative 2x squared plus 6 with respect to x. Integration. 4x, right, the x will go to x squared, and that 4 will get divided by 2, the new power, so that's 2x squared, minus 2x squared. Well, the x squared will go to x cubed, and I'll have minus 2 over 3, because I've divided by that new power. 6 integrates to 6x, and I will have my upper and lower limits. Substitute in your upper limit, substitute in your lower limit. Don't do any number work. You want to pick up a communication mark here. 3 squared minus 2/3 of 3 cubed plus 6 lots of 3. And I'm going to subtract whatever I get when I substitute in the lower limit. So 2 lots of negative 1 squared minus 2/3 of negative 1 cubed plus 6 lots of negative 1. Right, I'm going to save a bit of time and plug this into my calculator. So the 3, all of that comes out as 18. Plugging in the negative 1, that gives me negative 3 1/3. That is going to give me a final area of 18 plus 3 1/3. So 21 1/3 square units. Again, I have ended up with a positive area because I correctly had the top minus the bottom at the start here. Right, our third and final one here, calculate the area enclosed by y equals 7 plus x minus x squared, so a quadratic, and y equals negative 2x minus 3. We have got no sketch, so we're going to have to put that together for ourselves. The reason we are going to have to put a sketch together for ourselves is we need to figure out which function is going to be the one on top and which one is going to be on the bottom. Our sketch doesn't need to be a masterpiece here. A very rough one is all we need. We have got a quadratic. I know because the x squared term is negative, it's going to have this sad face shape. I know I'm going to have a straight line crossing through this because, well, it's told me it's going to be intersecting with this line here. So all I need to do is just draw a straight line on. I've got a gradient of negative 2, so that tells me it's going to be a downward slope that intersects. I know if there's an area enclosed between the two of them, I know I am going to have the quadratic on top and the straight line on the bottom. And that's going to be vital when I set up the actual integral. Before I do that, I need to find my two limits, and these are going to be the points of intersection between the two functions. So my points of intersection are when one function is equal to the other. So I'll say the straight line is equal to the parabola, and I need to bring all of this over to one side and solve, because I've got a quadratic equation there. So I'm going to add an x squared to each side. I am going to subtract an x from each side, and then I'm going to subtract 7 from each side. And that is going to give me a 0. The reason I've brought this stuff on the right over to the left is so I get a positive x squared there, just making this a little bit easier to factorise. X and x, negative 5, positive 2. So this tells me that x equals negative 2 is one of my limits, and x equals positive 5 is another one. So I'm just going to copy them across onto my diagram. Now, I'm not going to bother adding in my x and y axis here because they're not important. When we were working with a single function, so just a single curve or a single straight line, we needed to worry about whether or not we were above or below the x-axis. However, here, because our area is being trapped between a function and another function, where the x-axis is has no impact on what we do. This means we can just get stuck straight in to forming our integral and finding our area. So we are going to find the area by integrating between 5 and -2, top minus bottom with respect to x. Don't be lazy, write that down every single time. It will, 1, remind you need to do the top, take away the bottom, and 2, it's going to clearly communicate you know what you're doing. So the top is going to be this upper part here, so that is the quadratic, and the bottom, well, that's the straight line here. So I can put that together. Still need my integral symbol because I haven't done any integration. The top, 7 plus x minus x squared, minus the bottom with respect to x. Still not doing any integration. I'm going to multiply out these brackets and tidy up. So this is the equivalent multiplying that second bracket by -1. So I'll get plus 2x plus 3. Don't integrate that, tidy it up. 7 plus 3 is 10. X plus 2x is plus 3x minus x squared. 10, that is going to integrate to 10x. The 3x, well, the x is going to go up to an x squared, and I need to divide by that new power. So I'll have 3 over 2 x squared. My x squared, that will change to x cubed, and I need to divide that by 3. So 1/3 of x cubed. Copy across my limits. Now that I've integrated, I can substitute in my limit. So I'm going to substitute in the upper one, and then I'm going to substitute in my lower one. Alright, I'm going to use my calculator to evaluate this. So my first limit gives me 45 and 5/6 minus -11 and 1/3. So again, using my calculator, gives me a total of 57 and 1/6 square